Today we're going to be looking at the kinetic molecular theory and how it affects gas properties. Kinetic molecular theory says three major things. First of all, it says that molecules are moving. Secondly, all molecules at the same temperature have the same average kinetic energy. And as you increase the temperature, you increase the average kinetic energy. So, here we have a container, and in the container you have some gas molecules that are bouncing around, and on the side you have a histogram. And this velocity histogram, or energy histogram, shows that most of the molecules are low in energy, although every time one molecule collides with another one, you can have some energy transfer. And so there are some molecules that are particularly high in energy and velocity, but mostly the average is right there. As we increase the temperature, then the average moves up. The average moves towards the right, indicating that almost everybody has gained some kinetic energy, gained some velocity. There's a wider distribution. There are still some molecules that are low in kinetic energy, low in velocity, not moving very fast. But there are some molecules that are moving quite high. The average has increased, but the distribution has also increased. We increase the temperature even more. Finally, we have an even larger increase in the average. The vast majority of the molecules have increased in kinetic energy. There are still a few that are particularly low. There are still a few that are particularly high. But the average has increased, and the distribution has increased as well. It's a little wider. If we get a little ridiculous, wait till it comes to a balance here. And here we have the average also increasing. We still have some molecules way down on the left-hand side that are low in energy. We have a lot of molecules that are way up at the high end. The distribution is quite large. And just to remind ourselves what it looked like when it was cold, we'll decrease, we'll decrease, we'll decrease. And so as they collide, they lose energy, they lose energy, they lose energy. And now we're back to our relatively narrow distribution. Most molecules have low velocities. There are a few outliers, but not many. In our container, we have a number of molecules, and they're moving in all sorts of different directions. As they collide with one another, one molecule may gain energy. Perhaps this one collides with that one. And when they collide, perhaps this one slows down, perhaps that one speeds up. And so now you end up with one fast molecule and one slow molecule. But when the temperature is low, then your distribution is low, your average is low. So my graph might look something like this. On the y-axis we have the number of molecules, and on the x-axis we have velocity or kinetic energy. There are a few molecules that have low kinetic energy, there are a few molecules that have high kinetic energy, but the average is right in there. Perhaps this is at 25 degrees Celsius. However, as we increase the temperature, there are more collisions, there are more chances for molecules to collide. As they collide more often, there are more chances for them to gain or lose. And so what happens is you end up with a graph like that, where there is a wider distribution of possibilities and the average has increased. So perhaps this is at 45 degrees. As we increase the temperature even further, my graph starts to look like that. My average has increased and the distribution is wider. Perhaps this is 60 degrees. Properties of gases. Gases occupy much more space than what the molecules themselves take up. For instance, over on our left container here, we have our molecules all crowded in a corner, all bunched up. If we could collect them and put them together, they would not occupy very much of the volume of the container. However, because gas molecules are moving, when we let them go and release, they fill the container completely, and they effectively occupy the entire container. So it doesn't matter where you go in the container, you're going to find some gas molecules. They occupy a large volume, even though they themselves are only small. Gas molecules are very compressible. So our four major characteristics are: gas molecules occupy much more space than the molecules themselves. They expand to fill the container, which means they do not have a definite shape and they do not have a definite volume, and they're very compressible. The instructor should press start on the Centios. Students should be looking at question number 1 and answer the question: why are gases so compressible? A, because they are close together. What is being a little closer? B, they are so far apart, small changes are insignificant. C, gas molecules are not hard like solid molecules and can squish together. Or D, gas molecules are smaller than liquid and solid molecules. Instructor should press pause and wait for the responses to be collected.